Hello dear student, I am Manur Islam. Today in this video we are going to discuss an important question from CSIRNET June 2021. Okay, this is basically a question from part C and question ID is 5510. Okay, what is the question? The question said if R, suppose R plus with the set of all positive real number, and suppose f is moving from R plus to R is a differential function, and consider the function this gx equal to e to power x fx, in which of the following are true. Okay, so 4 options are given, 1 2 3 4. So we are going to verify each option one by one. Okay, so first option says if limit x to f is 0, then limit x to f is 0. Okay, for this option here what is f is a function from R plus to R. Okay, so see for option 1, I am choosing fx. Let fx to be cos x square by x. Okay, where x belongs to R plus positive real number. Okay, so it is very trivial that this function become differentiable. Okay, right, this function become differentiable because since x belongs to R plus, okay, x is a R plus means x is a positive real number, so lower part is non-zero and upper part is continuous. Okay, also differentiable, but the function is everywhere continuous, everywhere differentiable. Okay, so also lower part is continuous, x equal to 0, but here x equal to 0 is omitted, so this function become continuous. Also this function become differentiable. Okay, this function become differentiable, so this function become differentiable on R plus positive real number. Okay, now see for this function you can easily verify that limit x tends to infinity fx, this will be 0 since limitation fx what is fx, cos square by x. Okay, now you can write this, take let 1 upon x equal to y. I am replacing 1 upon x equal to y. If x tends to infinity, then we can write y tends to 0, x tends to infinity, 1 minus 0, so y tends to 0. So this implies y tends to 0. It 1 by x replaced by y, and it replaced by cos 1 upon y square. Okay, now it is bounded. This term is bounded. This term limit is goes to 0. X y tends to 0. Okay, so total limit goes to 0 by Sandwich theorem, because you can write 1 less than cos 1 upon y square less than 1. Okay, multiply by y, we get y cos 1 upon y square less than y. Now apply limit y to 0, then right side goes to 0, left side goes to 0, so in between, so in between, so it also goes to 0. Okay, so this is the limit, so this limit goes to 0. Okay, so we get limit x tends to infinity fx would be 0. Okay, so condition of first condition is satisfied. Okay, for option 1, limit x to fx equal to 0. Now if we check whether limit x to fx is 0. Okay, whether limit x to fx is 0 or not for this f. Okay, see for this f, if I differentiate f dash, if I find f dash x, what is f dash x? F is this, so f dash x will be x square x stop cos is minus sin x square 2x and cos x square x is 1. Okay, x is x square, this gives sin x square. Okay, and this gives cos x square upon x square. Now as previously, this limit goes to 0 as x tends to 0, as x tends to infinity, is x tends to infinity, this limit goes to 0, because this is 1 upon x square, 1 upon x square goes to 0, and this is boundary quantity. Okay, this is boundary quantity, and this 1 upon x square goes to 0, so overall limit goes to 0. Okay, but this limit is x tends to infinity doesn't exist. If you choose the function gx equal to sin x square, then this function, for this function limit at x doesn't exist. Limit x tends to infinity gx means sin x square, this does not exist. Okay, does not exist, this limit doesn't exist. Okay, because how we prove that this limit x tends to sin, limit x tends to infinity sin x square does not exist? How we prove? You have to choose two sequence. Okay, so I am choosing my sequence. Suppose xn equal to, one sequence is root under 4n plus 1 pi by 2. Okay, any natural number, and second sequence is this 1 upon root under 4n minus 1 pi by 2. If you choose this sequence, then see limit n tends to infinity, this goes to infinity, n tends to infinity, this goes to infinity. But see f of xn, if you find f of xn, this will be f of xn, not g of xn, sorry, g of xn. What is g of xn? If you place here xn, then it gives xn sin xn the square. So it gives sin xn the square, and sin xn square will be sin xn will be this. So sin xn square will be root under sin 4n plus 1 pi by 2, and sin 4 pi by 2 will be 1. Okay, so this limit, so gxn goes to 1. But if you find gyn, then you will get sin yn the square. Okay, and sin yn, this sin yn square will be sin 4n minus 1 by 1, and this equal to minus 1, and even in general number this equal to minus 1. So g of n goes to minus 1. Okay, as n tends to infinity. Yes, n tends to infinity. Okay, so see, if we have two sequences, both goes to infinity, but their functional sequence, one goes to 1, another goes to minus 1. So we can say that this limit, the limit of sin square as x to infinity does not exist. Okay, this limit does not exist. Since this limit does not exist, so you can say that limit x tends to infinity f dash x non-zero, because limit f dash is the nothing but the combination of two part. Okay, first part is this, and second part is this part limit 0, but this part limit doesn't exist. So overall this part limit doesn't exist. So this part, so limit f dash is not equal to 0. Okay, limit f dash is not equal to 0. So first one say limit f dash is 0, so it is not correct. Okay, so option 1 is incorrect. Now, but if it given that f is a continuous differential function, okay, and limit s to f dash exists, then it is obviously 0. Okay, but here is not given continuous differential, just given differential. Okay, getting my point? I am saying that if it is given continuously differentiable means f differential, f dash differential, so on, then in this case this limit exists and equal to 0. Okay, then in this case this limit exists. How this limit exists, you can easily prove. If it is given that it is continuously differentiable, so I am saying that if it is given, if f is continuously differentiable, it is given, if it is continuously differentiable, then in this case, then this limit exists, and also limit s into fx equal to 0, this gives, then it will imply limit s to infinity f dash x will be 0 in this case. Okay, and this is the question from CSIRNET December 2014. Okay, it's a similar question. Okay, but in this question is given only differentiable, the function is only differentiable. So in case of function is only differentiable, you cannot say this limit is 0. Okay, the example is this that I have given, sin cos square by x. Also you can choose this example, this example, sin x square upon x. This also example also work. Okay, for this example also limit s to fx is 0, because sin is bounded quantity, and this limit of 1 by x limit goes to 0, so overall limit goes to 0. But if you differentiate this, then you get similarly here cos of x square term. This for this and cos square limit doesn't exist. Limit s to infinity, cos square limit doesn't exist. So in this case, for this example also, you can get similar result. Limit s to infinity f dash doesn't exist. Okay, so if you want to verify this, as I have told in that question came though, then it is not very difficult. Okay, just write like this, limit x to infinity fx. You can write like this, limit x to infinity e to power x fx, and just up down it works adjusted. Okay, it was positive, so if you divide up down, it will give not effect. Yes, limit, then upper part limit s goes to infinity, lower part also limit s goes to infinity. So infinity uniform, so you can apply L-Hospital rule. If you apply L-Hospital rule, you get this e to x f dash x and fx e to x, right? And lower version e to x. So e to x, so it gives fx plus f dash x. If you take out the bracket, then limit f plus g will be limit f plus limit g. Okay, so I am writing this. Okay, now see, left hand part is same. Also given that it is 0, so both part cancel, so it imply limit is to infinity f dash x will be 0. So if it I am saying that if it given f is continuous differentiable, so means f is differentiable, f dash differentiable, f double dash differentiable, so on. continuous differentiable. In this case, limit s to f dash is 0. It is exist and equal to 0. Okay, but if it is not given continuous differentiable, just differentiable, if it is given just differentiable, then you can say if limit s to f is 0, then it f dash is 0. Okay, and also I given an example. Okay, so I think the option 1 is clear. Okay, why it is not correct, it is clear, so it is incorrect option. Okay, so now I'm coming from to second option 2. It is given that limit s tend to infinity fx plus f dash equal 0, then this limit is 0. Okay, so for this example, for this, what is given? Option 2. Okay, for option 2 it is given limit x tend to infinity fx plus f dash is 0. Okay, fx plus f dash is 0, it is given. Then I have to show that limit s to infinity gs minus gy by e to x minus y, this limit should be 0. Then it is correct or incorrect. Okay, I am verifying this. See here, what is g? G is e to power x fx, for f is a function of r plus 2r. Okay, so g is e to power x into fx, given g is e to power x fx. If you differentiate g, see it was a difference function. Okay, if also given that f is differentiable, so overall it is differentiable on r plus. Okay, so you can write like this. If you differentiate this, then what you get? You get e to x f dash x plus fx into e to x. Okay, so take e to x common outside, so you get fx plus f dash x. Okay, divide by e to x, you get g to x e to x, so you get fx plus f dash. Now take limit s both sides x to infinity. If you take limit s x to infinity, then this will give g dash x by e to x limit x to infinity fx plus f dash x. Okay, but this given 0, this limit given 0, this limit given 0, so put 0 here, so this limit becomes 0. Limit x to infinity g dash x by e to x, this limit 0. Name it 1 or star. I am naming it star. Okay, now see what happened. Now see what happened. I have to find this limit. Okay, this limit, so I am evaluating this limit. I am evaluating this limit now. Therefore I am writing this limit x into y into infinity. What is given? Gx minus gy upon e to power x minus y. I am dividing up down by x minus y. Okay, then no problem. X to infinity, y to infinity, up down divide by x minus y. If you divide up down by x minus y, then this gives e to power x minus e to x minus y. Okay, and I am replacing the function e to power x by, in lower part, e to power x by hx, replacing, let hx equal to e to power x. Okay, for x belongs to r plus obviously, because domain is given r plus. So if you write this, you get limit x to infinity y to infinity, this gives gx minus gy upon x minus y, this gives hx minus hy by x minus y. Now we all know Lagrange theorem. Okay, we know that if a function is differentiable on closed b, then we can apply Lagrange theorem. If b minus f by b minus y equal to f dash y, so gx minus gy by x minus y will be g dash y, and hx minus hy by x minus y will be g dash y. Okay, so I can write like this: limit x tends to infinity, y tends to infinity. You can like this, like g dash y, and lower part is dash y. Okay, for some j belongs to open x comma y, right? Open x comma y means j is in between x and y. Now see, it said x tend to infinity, but j is x less than j less than infinity. X tend to infinity means s can be made greater than however large number g. S can be made however large number g. Then also, then since j is greater than x, then j can be made however large number greater than g. Okay, this implies j tend to infinity. Okay, so you can replace x tends to this limit x tends to infinity by j tends to infinity. Okay, so if you replace j by x, then you get limit x tends to infinity g dash x by h dash x. Okay, but h dash x e to power x, so what is h dash x? e raised x e to x, okay. So h is e to x, the h is e to x, so write it e to x. So limit, you get limit x tends to infinity g dash x upon e to x, but this limit is 0, where I have proven in limit is 0 by star, okay. I have proved using g is equal to e to x of s, okay. So this limit is 0. So I, using star, I prove that this limit x to infinity y to infinity is minus 0 by e to x minus this limit has 0. So it is option 2, okay. It is option 2, right? So option 2 is correct. Now see option 3. It says limit x to f dash is 0, then limit x to fx is 0. It's possible? No. You can choose this function. For option 3, choose this function fx equal to 1, constant function for all x belongs to r plus. If you choose the function, it's constant function, then it is differentiable. Do you have any problem? No, because I think you have no problem, because constant function is every differentiable, okay. It's differentiable on r plus. If it, now it is, if you differentiate it, then you get f dash is equal to 0, okay. So I can say limit x tends to infinity f dash is equal to 0, but limit x tends to infinity fx is would be 1, okay, because f is a constant function 1. So limit x to f is 1. You can choose it not, you can choose it f is equal to c, where c is any non-zero constant, okay. I have chosen 1, so it gives c. The limit x to f is equal to 1 and it is non-zero. So see, for this example, if I choose f is equal to 1, then f is differential function and limit x to f dash is equal to, since f dash is equal to 0 for all x belongs to r plus, then it gives limit x to infinity f dash will be 0, okay. But limit x to f will be 1, non-zero, okay. But the third option says if limit x to f is 0, then limit x to f is 0. But in this case, limit x to f is 0, but limit x to f is non-zero. So option 3 is incorrect. So discard option 3. So option 3 is incorrect. Okay, so option 3 is incorrect. Now the left option is option 4. It said limit x to fs plus f is 0, then limit x to fs is 0. Okay, so I am going to verify option 4. See, for option 4, it is given that limit x to infinity fx plus f dash x will be 0. So you can write f dash x plus fx will be 0 for large values of x. G is how large, have a large number, okay. So large value x. Now if you like this, you could write dfx ds plus f equal to 0, okay. So it is linear equation, linear in fa. So if will be what, e to power dx means e to power x, I will be e to power x. So multiplying equation, I giving it name double star. So multiplying it by this I and integrating, we get, we multiply it by this I e to x, and integrating we get what? First of all, you get the linear equation. It is linear equation about linear equation in f, okay. It is linear equation in, it is linear equation in f. So you have to take f first, and then if I will be 2x, okay. And right side will be 0, right side 0, right side 0, right side 0, okay. So you have to take integration over 0 and into multiply if e to dx plus a constant c. So this become fx e to x will be c, but c is arbitrary constant, and then fx become c into e to minus x, okay. But c being arbitrary constant any. Now see, I am starting with this condition, okay, and they say that limit x to fx is 0. So try to find limit x to fx. So in case of this, limit x to infinity fx will be limit x to infinity c into e to minus x, right? C is a constant, so you could take it outside. So this become limit x to infinity e to minus x, okay. But this become limit x to e to minus infinity e to minus 0. So c into 0 is 0. So limit x to fx become 0. Limit x to become 0. Okay, so 4% correct. So in this question, so in this question, option 1 and 4 are correct, okay. So thank you. If you're in doubt, you can ask in the comment section. So thank you.